All right, the last way we're going to look at representing this particular situation, Miss Paxton-Hill has a recipe for punch that calls for 2 cups of cranberry juice and 4 cups of apple cider, is setting it up with something that looks like a fraction. Now, technically, it's not a fraction because a fraction means the numerator, the top number, would be a piece of something. So if I wrote n for numerator and d for denominator, that is technically a fraction. Where if I have, let's imagine I have a block here, this square, 4 parts would make this square. So we would write 4, right? Because there are 4 parts. And then let's imagine I just colored in 3 of them. That's the part, right? So this is a part of a whole. And that is a fraction. All right? Fractions are a special type of ratio, but not what we're dealing with in this particular problem. So it's just going to look like a fraction. So I want to label things still. So I've got cranberry and I've got apple. Okay? And I said that's going to be 2, 4. Does that right? 2 cups of cranberry. 4 cups of apple, right? And then I would think about it like making equivalent fractions. Whatever I do at the top, if I want to double it, I would do the bottom. 2 times 2 is 4. 4 times 2 is 8. These are equivalent. They mean the same thing. Let's see, maybe I'm going to double it again. Maybe I'm going to say 2 times 2, right? 4 times 2 is 8. 8 times 2 is 16. These are equivalent. And we can kind of show you what that means the same way we would show you equivalent fractions. So let's see, let me draw a square. Okay. Okay, here I have a square. Right? Let's zoom in on that. Here I have a square. And I want to start with this one, right? 4 equal parts. So my square is 4 equal parts. And in this ratio, I'm going to say I have 2 shaded ones represents the cranberry. Now, if I'm going to go from 2 over 4 and compare it to 8 over 16. I just want you to understand why these are equivalent. So here I've got 2 of the 4 blocks shaded in. The entire square we might consider one whole. Now imagine instead of dividing into 4 equal parts, I want 16 equal parts. So if I look at this and I divide each of these into 4, that is now 16 equal parts. And we can check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then if I look at the shaded part, it's 1, 2, 3, 4, 5, 6, 7, 8. 8. So I didn't change the size of the total square. I didn't change the amount that was shaded in. All I did was break it apart into more equal parts. So this is specifically how we would teach you about equivalent fractions. And remember, these are ratios that we're dealing with right now, not fractions. Meaning we're comparing the 2 and the 4 together. But we can still use this same concept to understand why 2/4 is equivalent to 8/16 is equivalent to 4/8. Or maybe we want to go the other direction. Half of 2 is 1. Half of 4 is 2. Those are equivalent. And we could check that with looking for our knowledge that we learned earlier. 1 is half of 2. 2 is half of 4. 4 is half of 8. 8 is half of 16. So that relationship is the same for all of those differently written ratios.